So we're gonna review section 8.1, 8.2, and 8.4 right now. Question 1. Dr. Smith would like to determine if there is a statistically significant difference between her two Math 1800 classes. To make this comparison, she will compare the results from exam 1 class. Class 1 had 33 students take the exam with a mean of 82.6 and population standard deviation. See what it says, guys? Population standard deviation. So let's write down the two classes right here. So question 1. So class 1, guys, and class 2. So class 1 had 33 students. You agree with me? It's N1 equals 33. Mean of 82.6. So X1 bar is 82.6. Population standard deviation sigma 1 is 1.41. Class 2 had 31 students. So N2 is 31 students. Take the exam with a mean of 84. And a population standard deviation. See, guys, it says a population standard deviation. So sigma 2 is 3.63. Can Dr. Smith conclude that there is a difference in the mean test grades between the two classes at alpha equals 0.05? So you guys agree with me that HO and HA must be mu1 equals mu2, mu1 not equal to mu2, because it says there is a difference. Difference, guys, means not equal to. That's the claim. And this is a two-sample z-test, as simple as that. How do I know? Again, it is a z-test because it gave me sigma 1 and sigma 2. So let's perform the test. It's number 3. Okay, stats, sigma 1, let's just copy the results. Sigma 1, guys, is 1.41, and now you need to copy sigma 2, 3.63. X1 bar is 82.6. N1 is 33. X2 bar is 84. N2 is 31. And we need to choose mu1 not equal to mu2, as you can see right here. And hit calculate if you like. So Z is negative 2.01 if you round it to 2 decimal places. And the p-value, guys, just look it up before I write it down, 0.0445. Okay. He wants that at alpha at 5%. It's less than alpha. So you reject HO. And what would be the conclusion? Can someone say it verbally here? So there is what?
Enough evidence.
Sometimes the book says sufficient evidence, but we're using enough evidence.
And the 5%.
At the 5% level of significance. You can say 0.05 or you say 5%. It's the same thing, guys. It depends on what the homework online has. To what?
Reject.
That I don't agree with. You see where the claim is?
To support.
Support the claim.
Correct.
Agree? There is enough evidence at the 0.05 level because we rejected HO, we support the claim when it is in HA. Remember, guys, this is HO and this is HA. You reject this, you support that automatically to support the claim. And what is the claim if you just want to write it down? that there is a difference in the mean test grades between the two classes. Yeah, there is a difference to support the claim that there is a difference in the mean test scores between the two classes. That concludes the review of section 8.1 using this question. Let's pick another one. You can see, guys, that the other one is, let's see. A survey found that the average hotel room in New Orleans is $88.55, and the average hotel room in Phoenix is $84.75. Assume that the data were obtained from two samples of 55 hotels each, and that the population standard deviation were 560 and 483, respectively. At alpha equal 5%, can it be concluded that the average hotel room in New Orleans cost more than that of Phoenix? It's the same test as the previous one, guys, because sigma 1 and sigma 2 are known, as you can see here, population standard deviation. So let's write them down for question 2. So we have, he started with the New Orleans and then Phoenix. So I'm going to label New Orleans as 1. And then Phoenix. So N1 is 55. He says 55 hotels in each. And that's 55. Then it says the average in the New Orleans is 88.50 and Phoenix is 84.75. Then he gives us the standard deviation of population, standard deviation of each, 560 and 483. And alpha is 0.05. Can it be concluded that the average hotel room in New Orleans cost more than that of Phoenix? Okay, guys, the New Orleans we labeled as 1 and Phoenix as 2. Now, if a student decided to label Phoenix as 1 and New Orleans as 2, then you have to reverse everything we do here to get the same results. So do you guys agree with me that he wants to check if the cost in New Orleans is more than Phoenix? So it's going to be mu1 greater than mu2. That's the claim. And mu1 less than mu2. And this is 2 sample z-test again. And if you ask me again, how do I know? Look from those values. Sigma 1 and sigma 2 are known. When they are known, you must use a 2 sample z-test. So let me just go back. And 2 prop z, not 2 prop z-test, 2 sample z-test. I haven't used data yet, so I'll do an exercise that has data in it. Sigma 1. Okay, let me just move it here. Sigma 1 is 560. Sigma 2 is 483. X1 bar is 8850. Just be careful as you enter your data. Review it before you hit calculate, just to make sure you didn't miss anything. 55. X2 bar is 8475. I mean, sometimes students forget the decimal point. That will destroy everything. So just be very careful here. And then we need to check that mu1 is greater than mu2. It costs more to lodge in New Orleans than Phoenix. So let's see if this is true. You want to do a draw? You can do that. So Z is 3.76, and look at the p-value, guys, 1e minus 4. Okay, I'm gonna just put that and explain it to you again, what that means. It means 0.0001, which is less than alpha, of course. Reject HO. And the conclusion, there is enough evidence at the 0.05 level of significance. We have enough evidence to what, guys? To support the claim, exactly. So you are saying you are supporting the claim. That's period. That's it. Whomever made the claim, you're just supporting it. You think that it is a true claim. To support the claim that it costs more to lodge in New Orleans than Phoenix. Okay, so that's question 2. We did that. Let's do 3. This is 8182, 8181, and then I'm going to do section 8.2 now. Question 3, just to reinforce what you learned, guys. A real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the value of homes. A random sample of the two groups appraised 10 homes. Is there significant difference in the values of homes for each group? Let alpha equal 0.05. Assume that the data are from normally distributed population and population variances are not equal. This means the pooled is no, guys. And that's a hint for you that it's going to be a 2-sample t-test. All right. Is there a significant difference in the values of the homes of each group? So can someone tell me what would HO and HA be here? Let me just put the labels. So what would it be? That's mu1, guys. And that's the second mean, the average. Significant difference means not equal. And that's equal. And you guys agree with me, it's going to be a 2-sample t-test. Why? Look, he gave me S1 and S2, not sigma 1 and sigma 2. So let's perform that. Stat tests number 4. Okay, X1 bar, 83,000. That's what the assessors, the real estate appraiser appraised the house. Average appraisal value of a house is 83,256. S1 is 3,256. N1 is 10 homes. And the tax assessors, they usually probably go a little bit higher because they want to charge us more taxes, so generate more revenues for the city. 2341 and N2 is 10. And you guys agree that it should be different from. Okay, pooled. We agree that when they say variances, population variances are not equal, making an assumption they're not equal, pooled means no. Make sure to select the no and press enter, guys. And now you want to see it in action. Here is the p-value. Looks small. Small p-value is low, HO must go. Yeah, it looks very low p-value, you will see. Okay, T is negative 4.020. 2-sample t-test. T is negative 4.0. Sorry, just let me put it back. Negative 4.020. P-value is 0.001, which is less than alpha, guys. Then you reject HO. And what is the conclusion? If you reject HO, you support HA. There is enough evidence at the 0.05 level of significance to support the claim that there is a significant difference in the values of homes, that there is significant difference in the values of homes between the two groups. You know, the tax assessors work for the city, and the higher the value of the house, the more taxes the city will generate. So usually they're not the same. All right, so that is question number 3. It is a 2-sample t-test, and I think we have one more question covered in section 8.2 here. We're gonna do that. Let me just do it. All right. A researcher suggests that male nurses earn more than female nurses. A survey of 14 male nurses and 22 female nurses. 14 male, since the males are labeled number 2, so it's going to be N2. And this is N1 equals how many females? 22. Reported this data. Is there enough evidence to support the claim that male nurses earn more than female nurses? Use alpha equals 5%. Assume the data are from normally distributed population, then population variances are not equal. That means the pooled is no, guys. Who can tell me how we're gonna state the null and the alternative hypothesis here? Just state them like that, and then put the signs. See something in the chat? Pooled is yes. A student is asking about pooled. When he says population variances are equal, pooled is yes. And when he says population variances are not equal, pooled is no. Here, look, he says population variances are not equal, so I'll use no. Okay, I need the signs, guys. He says,
Alternative is greater than.
so this one is greater than. Is that what you said?
Yeah.
All right, that is not correct.
No, it's gonna be mu1 less than mu2 because
And I know, guys, I know now you're confused because you see the word more and then you just follow that and put more. But look what he started with. He says male nurses earn more than female nurses. But remember, number 1 is not for the males, it's not for the females. So if I say, guys, I earn more than you, that means you earn what? So if I less, exactly. So if the males earn more than the females, that means the females earn less than the males. So that should be a less. And now it's the only reason why they were switching the language, because he started with females. He decided to put the females first. It doesn't matter. I could have changed this question, guys, and says, can you support the claim that female nurses earn less than male nurses? And then you just put the less and you be good, because number 1 is for females. So remember, that's number 1. I cannot change it here because he stated, he labeled females as number 1, so it should be less, which is the same thing, guys. I am older than you, you are younger than me. It's the same statement. Two sample t-test. And here's the t-test. All right, let's perform the test. Okay, X1 bar is females 23,750. Remember, and then S1 is 250. N1, I have 22 females. X2 bar is 23,900. S2 is 300. N2 is 14. And we're making sure that females, we're testing if females make less than males, which is the same thing as males making more. And we decided that pooled is no. All right, guys. Calculate. So T is negative 1.558. And look at the p-value. I'll just copy that. Zero 0.0661. Okay, what's alpha here? Alpha is 5%. That's bigger than alpha. I failed to reject HO. When you fail to reject HO, you cannot support the claim. There is not, if it is an HA, there is not enough evidence at the 0.05 level of significance to support the claim that female nurses or male nurses, that female nurses make less than male nurses. Or you can say that male nurses make more. It's the same language. So we cannot support the claim that the male nurses make more than female nurses. This is another example, guys, of section 8.2. I think I have one example from section, oh, that's 8.3. Okay. What I would like to do, I just want to go back to another example, just 1 second, and show you how to work with data instead of stats. Okay, we're going to do one of the worked out examples, question 2 in the handout. A sport analyst claims that the mean batting average for teams in the American League is not equal to the mean batting average for teams in the National League. So you guys agree that mu1 not equal to mu2 is the claim, and you can see that right here. Okay, because a pitcher doesn't bat in the American League. The data listed below are from randomly selected teams in both leagues. At alpha equals 0.05, test the sports analytic claim, assume population variances are equal. That means pooled is yes. That's the yes right here. Okay, what we did, guys? We put the American League data in L1. I put the National League data in L2, and I'm just going to go to two sample t-test. And look, guys, this time it's not stats anymore. He gave me the data. So my input is data. L1, L2, good. Don't change the frequency, never. And we're testing if they are different. So just not equal to. You can see the claim right here. Okay, and pooled, we decided it's a yes. And let me hit that draw. Ooh. T is negative 0.16. So probably this is not correct here. Negative 0.1169. I put 169. And then the p-value is 0.9089, guys, which is bigger than alpha. And if it is bigger than alpha, you fail to reject HO, and there is not enough evidence to support the claim. And you can see that. All right, so that's how we use samples where data is given to us, not the summary of the data. Okay, so that's section 8.2, and I'm gonna stop.